Alright, lesson 4.3 is solving quadratic equations by finding square roots. Before we begin with this, there's a couple of things that I want to review with you. And those are, first of all, just basic solving equations. I know we covered this a couple of units ago, but remember that whenever you have a 3x plus 4 equals 16, the equal sign is going to work as our divider. And when we solve this, remember we're solving for the x, so we need to subtract 4 on both sides. So 3x equals 16 minus 4 is going to give us 12, and then divide by 3. So your final answer is going to be x equals 4. Okay. On the next example, the first thing that we've got to do before we can solve it for x is distribute. So 2 times 2x is 4x minus 6 equals negative 22. Okay? And then we're going to solve it to get the x by itself. The first thing we're going to do is eliminate the 6. So we're going to add 6 to both sides. So 4x equals negative 16. And then divide by 4. So x equals negative 4. Okay? So essentially, when you're solving square roots, you're going to do exactly the same thing. Only add one additional step into it. But there's only a certain times that you can actually do this, okay? But before we get into that, I actually want to review the 25 first perfect squares. So all we're looking for is, we're looking for 1 squared, gives us 1. 2 squared gives us 4. 3 squared gives us 9. 4 squared gives us 16. 5 squared gives us 25. So at the time, go ahead and make a list of these. Go ahead and pause the video, and then go ahead and find the other remaining 20 perfect squares. And when you're done, go ahead and restart the video. Okay, so here's the list of actually the remaining 25 perfect squares. So for example, 6 squared would give us 36. If you took 12 squared, would give us 144. Now, one thing that when we're doing these, if you actually took the square root, let's say we took the square root of 625, square root of 625, then our answer is actually going to be 25, okay? And that's actually what we're going to be doing today. We're going to be working with square roots, okay? So, the very first thing that we're going to look at is, and any of these that are not perfect, we are not going to use this as a calculator. So, for example, if you were to find the square root of, let's go ahead and do this one with a calculator, okay? So if we went ahead and found the square root of 8, 8 square root would give you 2.828427, okay? That is not considered a perfect square. We're actually going to be simplifying square roots. Most of these, remember, back to lesson 1.1, would be irrational, and those are not exact perfect answers. So, but the square root of 36 is going to give us 6. The square root of 8, since it isn't perfect, here's what I want you to do. Find 2 numbers that multiply to give you 8. So for example, 4 times 2, okay? When you get a prime number, I want you to circle it. Remember, a prime number is anything that's only divisible by 1 and itself, okay? 4, we're going to split it up again into 2 times 2. So the way this works is, for every 2 numbers that you have, see we have 2 times 2 times 2 would give us 8. So for every 2 numbers that you have, then you're going to pull out one of those. One of those comes out. So it takes 2 to bring out 1. It's like a buy one, get one free, okay? Buy 1, or buy 2, and you end up taking 1 home. So, and then it's the square root of, and whatever's still circled ends up staying inside, okay? So let's go ahead and try another one real quick of those. So for example, if we wanted to find the square root of 27, okay? 2 numbers that multiply together to get 27 are 9 times 3. So 3 is a prime. 3, I get 3 times 3. Okay? So remember, for every 2, I'm going to pull 1 out front. Square root of, and I'm left with whatever's left inside. Okay? So let's try one more of those. So if I did square root of, let's say, 384, okay? If you're going through the list, you find out that you can take 384 is divisible by, say, 2. Okay? So 384 divided by 2 then gives us 192. Okay? And you can keep breaking this thing down, 192, until you find something that you know will work. So then I get 2 times 96. Okay? So let's go ahead and try to do this one. 96 divided by 2, I end up with 48. And 48 is not a perfect square, so let's take that circle off. Times 2. This one can be broken up into 6 times 8. Okay? And remember, 8, we just did one of those, takes 3 2s. 1, 2, 3. Okay? And 6 times 2 is going to give us 2 times 3. So remember, for every 2 numbers I have, I can pull 1 out. So here's 1, so I pull 1 out front. There's a 2, so I pull 1 out front. Here's a 2, there's a 2, so I can pull another one out front. Okay? And if you look, I'm actually stuck inside. I have a 3 and a 2. So then I would multiply. 2 times 2 times 2 would give me 8. 3 times 2 would give me 6. So it's 8 square root of 6. Okay? 324, if you remember back from our perfect squares, it's always nice if you can look back at this number. Here's 324, so the square root of that one would actually be 18. Okay? You can use a calculator to test them. So we could have taken, with our square root, I could have done 324, found the square root, and I would have found out that it is a perfect 18. Okay? So you can just write the 18. All right. A couple of other rules when you're simplifying square roots is if the square root is written as a fraction, what you're going to do is you're going to take the square root of the top number and the square root of the bottom number. So remember, the square root of 4 is 2, square root of 9 is 3. So it's 2/3. Okay? Unfortunately, sometimes they don't end up square root of 25 or the square root of 2. Square root of 25 is perfect. That ends up 5. However, the square root of 2 is not perfect. So what I have to do is I have to do what's called rationalize the fraction. And all that means is I need to get the radical out of the bottom. Okay, we can have no radicals in the denominator. An easy way to remember this is no rats in the basement. Okay, basement being the bottom. Okay, so no rats in the basement. So if we multiply, we're going to multiply by square root of 2 over 2, which is just a form of 1. Okay, so 5 times the square root of 2 is 5 square root of 2. Square root of 2 times the square root of 2 would give us the square root of 4. But remember, the square root of 4 is 2. Okay. One thing to keep in mind is you will need to simplify those. Should you be able to simplify those numbers. Okay. All right. Next example. So if I look, I want to simplify the square root of 500. So I'm going to look for 2 numbers that multiply to get me 500. So 2 numbers that multiply to get me 500 would be 5 times 100. Okay. Now, if you can automatically think of 2 numbers that multiply, or the same number that multiplies to get it. So for example, 100 would be 10 times 10. So remember, every 2 I pull out 1. So I pull out 1, and the 5 is stuck inside. So 10 square root of 5. Okay. The next one, whenever you're multiplying like this, you can multiply 3, and then 12 times 6 would give you 72. As long as you're multiplying everything that's under the radical times everything under the radical, and anything that's outside times the outside. Okay? And you quickly find out that this is 2 times 36, and 36 can be 6 times 6. So for every 2, we pull 1 out, and we're always going to multiply. 2 stays inside. 3 times 6 is 18, square root of 2. Okay? All right. This one, remember, we can't have any radicals in the bottom. So we're going to multiply by the square root of 3 over the square root of 3. Actually, let's back up a second. First of all, we can find the square root of 25, which is 5, over the square root of 3. So multiply by the square root of 3 over the square root of 3. And I end up with 5 square root of 3 over the square root of 9, 3 times 3. But remember, the square root of 9 is 3. Okay? And also, when you take a radical times a radical, they actually cancel each other out. Okay? All right. So for the last example, remember, square root of 2 over the square root of 11. Square root of 2 is not perfect, so I'm going to rationalize it. So 2 times 11 gives me the square root of 22. Remember our shortcut, when we take a radical times a radical, they disappear and we get 11. Okay? All right. Now for part 2 of this, what we're actually doing in the second part is we're actually going to solve this. Now remember, if you remember, our original formula was ax squared plus bx plus c. In order to solve this by using the square roots, you cannot have any bx term. Okay, so in other words, you can have an ax squared and you can have your constant, but no plain x term. Okay, so it only works when you have an x squared term is the only variable that exists. Okay, and the other thing is, just like you're solving your equations, eventually you need to get the x squared term all by itself. Okay, just like solving an equation. So the example on this is, the way you get rid of this squared is you're going to take the square root of it, because a squared and a square root, I'll back up a second. Remember, whatever we do to one side, we have to do to the other side. So we're going to square root 25. So a square and a square root cancel each other out, and I'm left with just x. The square root of 25 is 5, but we need it to be a positive or a negative 5. Because if I took, when I plug it in, 5 squared is going to give me 25. And if I take negative 5 squared, it also gives me 25. Okay? All right. So let's take a look at another example when it's not already x squared equals something. And in this case, I have x squared minus 6 equals 30. Well, all you're going to do is you're going to solve it for the variable just like we did before. So you're going to add 6, and you're going to add 6. So those cancel, and I get x squared equals 36. And then the way I remember, in order to get rid of this squared, I'm going to take the square root, and I take the square root of this side. So the square and the square root cancel out. So x equals square root of 36 is 6. But remember, I get 2 answers, a positive 6 and a negative 6. Okay? All right. The last example just takes it one more step farther. Just remember that all of your x squared terms have to end up on one side, just like you were solving it for a variable. Okay? So we're going to solve this for 2x squared. So we're going to minus 1, minus 1. So I end up with 2x squared equals 16. And then make sure you divide by 2, because our end result is we've got to get the x squared all by itself. Okay? And then divide this side by 2, so I end up with 8. Take the square root, take the square root. So those cancel. X equals, and remember, 8 is not a perfect square, and we do not want the decimal form of this. So we're going to break it up, 2 times 4, and this is 2 times 2. So for every 2, we pull out 1, and we have 1 2 left inside, and it's a positive and a negative. Okay?